Hi there, it's Jason Gorman from Codemanship with the first video diary entry of 2022. Happy New Year. Before we start, if you're finding these videos useful or amusing, please like and subscribe and ring the bell for notifications. So I'm one of these people that needs to kind of keep abreast, keep up with trends in software development. And one of the ways that I do that is to browse the job listings on various job sites to see what kind of skills people are asking for, what are the practices and the techniques and the technologies that are currently in vogue or that are becoming more popular. One of the things that I see very often when I'm browsing those job listings is teams hiring test automation specialists, people who specialize in writing automated tests, typically at the system level. So tests, for example, that drive an application through a web browser or drive an app through a smartphone or drive a web service from the external point of view, using tools like Postman, for example. Now, I'm not about to say that you shouldn't do that and that you don't need these people. I'm going to be saying the exact reverse of that. But I just wanted to talk a little bit about what are the risks of automating tests at the system level. And to start with, I just wanted to remind you all about this thing called the testing pyramid. So if our test suite is healthy, that means that it runs fast. The faster our tests run, the faster our build and test cycles will be. And if you've watched previous videos on those innermost feedback loops of software development, the build and test cycle in particular, you'll see what can happen when our build and test cycles are too slow. Now, typically, the bulk of the time that it takes to do our builds is the time that it takes to run the tests on any software of any appreciable size or complexity, because there are usually thousands of different tests that we need to run. So we want to engineer or optimize our test suites to run fast. And that means if we were to visualize our test suites in terms of how long they take to run, so we sort of organize them on a graph like this one, we would hope that it would form a kind of pyramid shape where the base of the pyramid, the bulk of the tests run the fastest. So let's call those unit tests if you like. But when I say unit test, I mean fast running test, a test that does not involve any external dependencies. Basically, it doesn't read data from files, it doesn't talk to databases, it doesn't call web services, that kind of stuff. Tests that don't involve external dependencies. And they would run in the order of milliseconds, hopefully. Those unit tests, and I use that term advisedly, would test all of the internal logic of our code, basically. We're aiming to test all of the internal logic of our code with unit tests. So if all of the internal logic has been tested, what's left to test? Well, just because the pieces of the jigsaw are all correct individually, it doesn't mean those pieces are going to fit when we try to put them together. So we need to test the contracts, that contracts are being observed between the different components of the system. For example, when we call a web service, we need to make sure that we're calling it correctly and that it's responding correctly, that we're obeying the contract. So we can write integration tests to do that. And those will run in the order of hundreds of milliseconds. And then finally, what's left to test? Well, if you've ever heard yourself say out loud, it worked on my machine, the final thing that we need to make sure is that it's not just working on our machine, on our desktop, for example, but it actually works in whatever target environment or environments it's intended to be run in. So we test the configuration, the system configuration. And I've seen many examples. For example, I did one quite recently where a bunch of tests were failing in the build environment because the date system was different. Basically, it was in a different locale. So you need to test for that kind of thing. Similarly, you might test for a web app in different browsers and different configurations of browsers and so on and so forth. So the tip of our test pyramid is those sort of system level tests. And what you're aiming to avoid is completely relying on those. Ending up with an upside down test pyramid, basically, where the bulk of your tests are system level tests that run slow, and you're relying on those to test the internal logic of your application. We'll talk about that in a minute. So the tip of your pyramid is system tests, and they're there really to just check that when we put all of the pieces of the jigsaw together and deploy it into a certain target environment, that the whole thing sort of works. It hangs together as a whole. And for that, we would aim to have the fewest number of tests we can get away with because they're the slowest running. So we would cherry pick, for example, user journeys that hit every part of the system so we can make sure that everything is working in that environment. Now, that's not the only use of those kinds of tests. We'll talk about that later. But in terms of day-to-day testing, the tests you would run as part of your continuous integration builds, for example, you need that suite to be fast, and therefore you need to be a pyramid the right way up with the fewest number of system tests, basically, that you can get away with. Okay, so we'll talk a little bit about how we can end up with a pyramid the right way up or upside down. And with this example, let's imagine an online shopping application, a sort of Amazon-style app, and we want to check out. So we've added a bunch of stuff to our basket, and now we want to check out. Now, we could choose to test this through the browser. So we might write a test script that actually adds items to a basket, clicks the checkout button, and waits for the response, waits for it to load the checkout page, and then parses out the total of items in the basket so we can check that that total is calculated correctly by our system. But that would be a very inefficient way of getting that number, a very inefficient way. It would be much better and much simpler to actually test the module in the system that does that calculation, to write a unit test for our basket module here, for example, so we can check that the total is being calculated correctly there. That test will be much simpler. It'll run much, much faster in milliseconds rather than seconds. It'll be much less likely to fall over because of connection problems or the website not responding or something like that. So it'll be much more reliable as well. And also it would have the added advantage of if that test was failing, then we know where in the system the error is actually occurring. Whereas if tests are failing at the system level, at the boundary to the system, then we may have to go in and try and figure out, okay, where is it actually going wrong? Now, in order to achieve this, in order to be able to test that logic in isolation, the logic needs to be isolated. So we need to have, good separation of concerns between how, for example, that basket total is displayed on the web page is one concern, but how that number is actually calculated is a separate concern. And we want to test those things separately if at all possible. Now, I worked with a client a few years ago now who had a core software product, very successful product, but they were in a situation where they were completely relying on a suite of thousands of browser-based tests automated using a tool called QTP, which is a very powerful but very expensive tool, very expensive. And the test automation specialist that they hired, because before that they were testing it manually, which is an order of magnitude worse than having automated browser-based tests. So that was definitely a step in the right direction, but they'd ended up in a situation where they were totally reliant on this suite of automated browser-based tests to check all of the internal logic of their app. And that took 24 hours to run. But because they were browser-based tests, they're flakier, they're more complex, and they're more liable to fall over or time out than unit tests. And therefore, it was very rare to be able to run the entire, well, I don't think it ever happened, to run the entire test suite and have all of the tests executed one after the other. It kept stopping, basically. So that expensive and very highly skilled test automation expert, she had to spend 3 days, 8 hours a day for 3 days, essentially watching the tests run, basically. A bit like paying someone to watch your washing go around in the washing machine. Not a very good use of a tester's time and expertise. Not a very good use at all. But it also meant because the test took so long to run, they were only running them once every fortnight, basically. So they were, over the course of a fortnight, you got this development team making all kinds of changes to the code and then finding out at the end, after a fortnight, that they'd broken a bunch of stuff. So this was causing them major, major headaches. If you recall my videos from last year on the impact of the length of that build and test cycle on all the other feedback cycles, the outer loops in software development, they ended up with really long lead times. They had a backlog of change requests going back, I think it was 2 or 3 years. A whole bunch of stuff got deprioritized, a whole bunch of changes got cancelled. A lot of customers got very angry. This is what happens when you start saying, no, you can't have that, or I'm sorry, that's not going to happen now. We've decided not to do that. So it was really, really hurting them as a business. This is what tends to happen. So you want to seriously avoid ending up in this situation. Now, when I see teams advertising for test automation specialists, I worry that this is what they're going for. Maybe they're moving from a situation where it was mostly manual tests, and there's still plenty of teams that do that, to a situation, and no doubt an improvement, but a situation where their test suites look like this. And this is a bit of a dead end, I'm afraid. Really what you need to be doing is moving towards unit testing as much of your logic as possible, and very often this requires you to refactor the internal design of your software so that it is more unit testable, so you have that separation of concerns. And this is a process that's described beautifully in a book called Working Effectively with Legacy Code by Michael Feathers. So just to be clear, and we're going to take a look now at a very popular tool for automating browser-based tests called Selenium. Okay. Now, Selenium was developed by the folks from ThoughtWorks, as are many useful and wonderful tools. It has an illustrious history. It's very popular for this kind of work, for automating tests that drive an application through the browser. It has other uses as well, as they're clear, as they make very clear on their their homepage there. But the idea is basically that you can write tests that drive a browser at a high level, that fetch web pages, click buttons, enter text into text boxes, etc., etc. So you can drive an app, but at a level of abstraction that makes it very easy to write those tests. And this is a tool that I would, ideally use to write those high-level system tests, to that cherry picking of user journeys, so that there would be a handful, maybe a few dozen Selenium tests in our build test suite and our continuous integration test suite. And everything else would be tested by unit tests, which means that person you're hiring to write those Selenium-based tests, for example, or those QTP tests or whatever tool you're using, is not going to be doing a lot of test automation at that level in that kind of way. So what would that testing expert be doing? Now, this is where people often read me wrong. They think when I say don't automate lots and lots of system tests as part of your regression test suite, they think what I'm saying is don't hire these test experts. That's not what I'm saying at all. There are far more valuable things that a testing expert could be doing on a development team. And I'm going to give you 3 examples, one of which would involve, potentially a tool like Selenium. Now, the first thing that a tester could be doing, which is far more valuable than watching the washing go round and round in the machine, or even writing scripts, automated test scripts. Testers bring something to the table that development teams often lack, and that's that they think like testers. We tend to be very happy path oriented. Well, it does the thing it's supposed to do, and we're kind of done now. And maybe we find a couple of edge cases that we thought of. Testers tend to be much smarter than that in figuring out, okay, but what happens if we do this? But what happens if we do this? What happens if we leave that blank? What happens if we press the back button on the browser? So they're very good at the what ifs, and they can be very structured about it. The best testers are very good at organizing their thoughts, using techniques like decision tables, state machines, path-based testing, combinations and permutations, and all of those very useful techniques for finding the test cases we didn't think of. Now, you have a number of choices here as to when you might ask them to do this. The most expensive and the least efficient time to think of those test cases is after we've built the software. So paying someone to write thousands and thousands of system tests, using their testing expertise to find the test cases we didn't think of, is the most expensive way of doing it, because that means that we're going to get into bug fixing territory in big feedback loops. Someone's going to have to report the bug, have to schedule the bug fix. The developer then has to go back and understand the code, and et cetera, which might be code they wrote themselves weeks ago. So I found that is not a good use of a tester's time. We can shift them up the process, the development process, and rather than having them write the automated tests, have the developers write them mostly as unit tests, and have the testers pair with the developers, spend time with the developers. So as they're writing the code, hopefully you're a tester who can understand the code, and if not, you'll soon learn. Then you can start pointing out the what ifs, but what if this, what if that, etc., and feeding that back into the overall design process. So you become part of the design and development process. So if your team, for example, does test-driven development, you essentially become a testing expert within that process. And that tends to be a much better, much more efficient use of a tester's time. But many of those what ifs will be things that, if we deal with them, will actually change the user experience. They'll change the functionality of the system at the system level. So we need to really move the testers up another step, left shift them, if you like, further up the process, so they're actually in the room when we're talking with the customer about the requirements. So they can test our understanding of what the software is supposed to do. They can spot those but what ifs before we've written a line of code, before we've even thought about writing code. They can debug our software. They can catch bugs before any code has been written. They won't catch all the bugs. We're still going to need those automated tests. But they can catch a lot of misunderstandings and a lot of what ifs, a lot of edge cases before a line of code has been written by if they do it in a smart way, by utilizing their testing expertise to find the cases, to explore the overall behavior, to explore the state space of the application before we've written a line of code, using things like wireframes and storyboards and state machines and so on and so forth, and combinations, permutations, truth tables, decision tables. Move all that stuff up so the tester is involved in actually designing the system, thinking of the test cases that it should need to handle. It will really, really pay dividends, because something that if we were to catch it after we've released it, or even after we've shipped it into testing, the cost of fixing it on a whiteboard is 1,000 times cheaper, basically, and 1,000 times easier. And then those tests will eventually become unit tests, etc., etc. Now, so testers can, instead of doing after the fact testing and test automation, they can actually pair with developers and help them write better tests. That's a really good use of a tester's time. But a much better use of a tester's time is to actually have them involved at the beginning of the design process. When it comes to thinking of test cases, if you're doing specification by example and test-driven development, the line between specification and testing is very, very blurred. A test is a specification, and therefore that's where the testers will add the most value. But that's not to say that their system testing automation skills will not come in useful. So the last thing I want to talk about, and Selenium is a really good example of this, is the test cases that, despite the fact that we analyzed the requirements, despite the fact that we had developers writing really good unit tests, what is it they say? There's many a slip twixt cup and lip. Inevitably, there will be things that we missed. There are always things that we missed. So there is a need for what we call exploratory testing. That is to take the software that has been delivered, that passes all the tests we thought of, and continue to hunt for those test cases that we didn't think of. So Selenium has an IDE that you can basically, you can record test scripts. So it's very cheap for a tester to just go through and click all buttons and try different things and go, well, I wonder what happens if I do this. I wonder what happens if I do that. And they can record those scripts very easily. And those scripts can then become the basis. They essentially reproduce a bug that the tester has found. They can then become the basis for a unit test and then a bug fix later. And again, it's always that kind of workflow of, if we find a system test that fails when all our unit tests are passing, we haven't discovered a new system test. What we've discovered is a missing unit test. Now, exploratory testing is great. Manual exploratory testing is something that a good tester will do well, but again, they will probably be quite organized about it. So they won't just be randomly, well, hopefully not just randomly clicking things and doing things like that. They might get organized and sort of break it down into, for example, breaking a user interface down into state machines so that they can exercise all the different paths that they think are interesting, and so on and so forth, or trying different combinations of inputs. And therefore, they might want to test those exhaustively. This is similar in a way to property-based testing. If you've got into that, where you have a parameterized unit test, where you're actually generating the test inputs as randoms or ranges of numbers or sequences of inputs and so on and so forth, so that you can more exhaustively cover all of the different possibilities automatically. You're generating the test cases. And this can also be done at the system level using a tool like Selenium, and where, for example, you might have thousands of potential different browser combinations that you want to test at different types of browser, different versions of browser, different browser configurations. And you might want to test your application in as many of them as possible. And this is where scaling up really comes in. For those kinds of tests where there are thousands of cases you need to cover, first of all, you're not going to run those tests every night. The purpose of those automated exploratory tests is to find the test cases we didn't think of and turn them into unit tests that become part of the main suite, your everyday suite. These kinds of exploratory tests, let's call them our Sunday best tests, the most exhaustive tests. You might run them overnight, for example. And also using something like Selenium Grid, you can scale them up. You can throw hardware at these tests. So you can parallelize them and have dozens of different nodes on Amazon EC2, for example, or something like that. Running different partitions of the tests and so on and so forth. So there are many options there. And by the way, if you have ended up with a large suite of automated system tests that you're relying on to test the logic of your application, all is not lost if you are using something like Selenium. And because it's open source and because it's free, you can run as many different instances of the Selenium test runners as you like, which means you can just throw hardware at the problem if you have to, as an interim solution to get you to a point where your suites are running in minutes and not hours, for example. So not ideal, but it can be done. And it takes a bit of engineering, takes a bit of thought, but it totally can be done. And it's low-hanging fruit. But one of my favorite uses of sort of cloud-based, grid-based testing, if you like, parallelized testing, is this kind of very exhaustive exploratory testing, where we're testing all possible combinations or all possible paths that we think are interesting, and so on and so forth, so that we can find those really, really, really deeply hidden bugs that no one would have thought of. Okay, so that's kind of the end of my diary entry for today. I'm just absolutely clear again, I'm not saying don't hire testing and test automation experts for system level testing. Those kind of tests definitely do have their uses, they have their place, but test experts, people who think like testers, can add a lot more value to a team if you involve them sooner, not after the fact automating system tests, but working with developers automating unit tests, and very importantly, working with development teams and customers and user experience designers and other people involved in the design process as part of specification by example to catch those bugs before we've even written a line of code. Anyway, I hope that's useful advice for you. It's 2022, we're still in the pandemic, but hopefully we can see the light at the end of the tunnel now. Stay safe. Until the next time.